playing around with polarized light. Sunlight is unpolarized, so it doesn't really matter what angle that if I use a polarizing filter. If you have two filters and they're polarized in the same direction, then essentially nothing too interesting happens. If the polarizers cross, then essentially light making through one filter is horizontally polarized. Then the next filter only lets through the light that's vertically polarized, so cumulatively nothing makes it through. This is used to have adjustable filters in photography fairly often. Now, something really interesting starts to happen, and in fact, a quantum effect begins to kick in.
What is X-ray diffraction, and what is it used for? In an X-ray diffraction experiment, a sample is placed into the center of an instrument and illuminated with a beam of X-rays. The X-ray tube and detector move in a synchronized motion. The signal coming from the sample is recorded and graphed, where peaks are observed related to the atomic structure of the sample. Most materials are made up of many small crystals, like sand on a beach. Each of these crystals is composed of a regular arrangement of atoms, and each atom is composed of a nucleus surrounded by a cloud of electrons. It's at this scale that the story of X-ray diffraction begins. X-rays are high-energy light with a repeating period called the wavelength. Since the wavelength of an X-ray is similar to the distance between atoms in a crystal, a special interference effect called diffraction can be used to measure the distance between the atoms. Interference occurs when X-rays interact with each other. If the waves are in alignment, the signal is amplified. This is called constructive interference. If the waves are out of alignment, the signal is destroyed. This is called destructive interference. When an X-ray encounters an atom,
reaction in nuclear fission. When slow neutrons are bombarded on uranium, each uranium nucleus is broken into two almost equal parts, and along with it, enormous energy and 2.3 trace neutrons are emitted. If the conditions are favorable, these neutrons take part in the fission. This leads to a chain of nuclear fissions, which continues till the whole of the uranium is consumed. Thus, the energy produced keep on multiplying. We have seen that about 200 mega-electron volts of energy is released due to fission of one uranium nucleus. In this chain reaction, the number of nuclei undergoing